Hello, now we are going to look at one of the versions of the equation of the line. And the version we will look at today is y minus y1 is equal to the slope m times x minus x1, where x1 and y1 is a point on the line and m is the slope of the line. And this formula is found on page 18 of the formula tables or log tables. This formula comes directly from rearranging the slope formula that we already know. So if we knew the slope m, we multiply both sides by the denominator of this fraction and you effectively end up with this formula. So it is simply a way of taking the slope formula and using it, if you already know the slope, to describe all of the points in a set, all of the points in a straight line. Remember, this slope formula just means the change in y divided by the change in x, which we can also visually talk about as the rise divided by the run. So let's put this formula into practice. Find the equation of a line L with the slope of the line a third and the point C, here in green, at 3 minus 4 is an element of L. So we're using this set notation because a line is a set of points. So we have a description of the set is what the equation of the line gives us. And we want to have our final answer in the form ax plus by plus c is equal to 0. And this is one of the forms that we can be asked for our line in an exam. So in this case, we can see from our formula, we need the slope and we need a point on the line, and we've been given the slope and we've been given a point on the line. This is our x1, this is our y1. So we can simply sub into this formula and then rearrange it into the form we've been asked for. So we've already got the two pieces of information we need. So we write down our formula. Y minus y1 is equal to m on x minus x1. We write down our slope, a third, and we write down our point. C is at 3 minus 4. Have all of our information immediately next to us as we sub into the formula. And this helps avoid making any errors. So we have minus 4, everything gets subbed in brackets, minus 3, and we tidy things up. Y plus 4 is equal to a third on x minus 3. You could multiply in this bracket, but we don't really want this fraction here, particularly if we're going to give our answer in this form. So what we're going to do is multiply by the lowest common denominator of everything on both sides. Well, the denominator of everything else is just 1, so that means our lowest common denominator for everything is going to be 3. So we multiply both sides by the lowest common denominator, and that will essentially get rid of this fraction here, because we have all of this side is divided by 3, because it's multiplied by a third, so 3 multiplied by a third is just 1, so the e fraction goes away here. And on the left-hand side, we have to multiply out this bracket now. So we have 3y minus plus 12 is equal to, we just have 1 times this bracket here now, so that's just going to be x minus 3. And now we rearrange it into the form that we want. So in this case, I'm going to subtract 3y from both sides. And I'm going to subtract 12 from both sides. So I end up with 0 is equal to x minus 3y. I can't add that to anything, but I have subtraction I can do here because I have minus 3 and minus 12. So I end up with minus 15. So that is in the form that I was asked for. It's x with y with the constant is equal to 0. So that's my final answer. Now we're asked to find the equation. Actually, before we go on, I'm going to draw in that line. So visually, so this is the equation of the line, and visually I say, how am I going to draw this? Well, I know the line goes through the point 3 minus 4, the point C as I've labeled it here, and I know it has a slope of a third. That means that if I go from a nice point where it crosses the grid, which it necessarily does at 3 minus 4, if I run across by 3, I rise by 1. If I run across by 3, I rise by 1. So I'm able to use the slope to figure out where I should cross the axes, cross the grid lines again, and that allows me to get some points, and then I can use a ruler to draw through and get my line drawn so that I have a better feel for what this line looks like. Now, let's continue on with the equation of AB. So in this case, I have to go to my image here and I say, well, A is at -1, -2 down here, and B is at 5, 7. Those are my 2 points, and I write down the equation of my line. And I say to myself, well, what do I know? What do I need to know? Well, I have a point on the line. Say I could call A x1, y1. So I have a point on the line. I could also have picked B as being x1, y1. It wouldn't have made any difference. But I don't know the slope. So I need the slope of AB. So how am I going to get that? Well, I have 2 points that are on the line. That means I know I can use my line formula. So I can tell myself the story of what I know. I am asked for the equation of AB. I know that's a line, so I write down the equation and line formula from my formula tables. And I say, well, I have 2 points. That means I have the point I need, and I can use the slope formula to get the other piece of information, the slope that I need. So we write down the points, we write down the formula we know for getting the equation, and then we're able to work out how to get to the answer we want, to get to our final equation. So for the slope formula, I'm going to call that x2, y2. And now I'm going to get the slope, and once I have the slope, then I can get my equation. But I need to be able to tell myself the story of what it is I'm doing in order to be able to do the question. So for getting the slope of AB, I have my points here and I have my slope formula. So now I can sub in, and everything goes in brackets. So y2 minus y1. Again, we can see here minus by minus, we're going to end up with a plus. If we didn't write in brackets, it'd be very easy to miss that and lose marks. And then we have 5 minus 1. So we end up with 9 all over 6. And I see I have a common factor of 3. So I divide above and below by 3, or take out the common factor of 3. And I end up with 3 all over 2 for my slope of AB. And now I can sub in y minus y1, or my y1 I already have, is going to be minus 2. So I'm just going to pick the A as being my x1, y1 here, because it's already labeled as such, and it's a point on the line, so it works. I have my slope of 3 over 2. And I have x minus x1 is minus 1. And everything goes in brackets. And so I have y plus 2 is equal to 3 all over 2 on x plus 1. I don't want this fraction here, so I'm going to multiply both sides by the lowest common denominator. In this case, the only fraction involved is, again, 3 over 2. So my denominator, my lowest common denominator for everything, is 2. So I multiply both sides by 2. That 2 divides out to 1 the other 2. And now I have 2y plus 4 is equal to, now I have 3 multiplied by this bracket, so 3x plus 3. And in this case, again, we may as well rearrange it in the form ax plus by plus c is equal to 0, just for the practice. So we have minus 2y, we have minus 2y, minus 4, minus 4. And I end up with 0 is equal to 3x minus 2y minus 1. And finally, find the equation of the line k, where k is perpendicular, so our upside down t-square means perpendicular to the line AB, and it goes through the point 6, 2. So let's draw that in. So we know that our line k is perpendicular to AB. That means it's at right angles to AB. And we know that it goes through the point 6, 2. So our line K must pretty much look like that. It's going at 90 degrees or at a right angle to the line AB, and it's going through the point 6, 2. So we now know what K should look like. Let's see what we get for its formula. So if K is perpendicular to AB, well, perpendicular, we immediately think of slope. So if we're asked for the equation of K, we should actually start off with the equation of line formula. So y minus y1 is equal to m on x minus x1. And then we say, what do we know? What do we need to find? Well, we have this part sorted. We've got a point on the line. That's our x1, y1. So what we're missing at the moment is the slope. So the slope is going to be perpendicular. It's going to be the perpendicular slope to AB. So how are we going to get that? Well, we know that if we multiply a slope by the perpendicular slope, we must get minus 1. And we know the slope of AB. So the slope of K multiplied by the slope of AB must give us minus 1. So the slope of K times 3 all over 2 must give us minus 1. And we multiply both sides by the common denominator to get rid of the fraction. And we get 3 times mk must equal minus 2. And divide both sides by 3 to get the slope by itself. And so we have the slope mk is equal to minus 2 all over 3. And now all we have to do is sub into our line formula. So we now know all of our information. So y minus 2 from our 0.62 times the slope, minus 2 all over 3, on x minus 6. And we tidy that up. And we get, put a line across here. We get minus 2 is equal to minus 2 all over 3 on x minus 6. And we tidy up our equation the same way as we have before. And when we have tidied down, gotten rid of our fractions and rearranged into the form that we are looking at the moment, we have this for the equation of K. So again, when we're looking at the equation of the line, if we're asked for the equation of a line, we know that we need the slope and we need a point on the line. And if we're given more than one point on the line, or if we're given a visual that we can find points on the line from, then we could use our slope formula to get the missing slope if we needed it. We may also be directly given it, like we were in the beginning question, but often we will have to find multiple points on the line, use the slope formula, and then use the line equation. And that is what we need for now.